Hi, my name is Núbia Silva, and I will present a multiple strategy for plant species identification using images of leaf texture. It is estimated that there are about 300,000 plant species on our planet. This number suggests that the identification of plant species, although is a classic biological problem, it still requires the attention of researchers. Aiming to overcome this challenge, the search for alternative solutions to plant species identification has emerged. Methods that make use of computer vision for plant identification are a very interesting alternative because of their automaticity, the easy aggregation of new information, and more agile classification compared to that made by taxonomists. The literature presents several methods for plant identification, which can be classified according to visual aspects. And also, computational methods are not yet as accurate compared to human identification, which motivates further research aimed at further exploration of this area. In this work, we will use local phase quantization as a feature structure to identify the species. Several features can be used for plant species identification, such as color, shape, and texture. The main process is composed by image acquisition, feature extraction, and classification. We can use several kinds of methods, and in this work, we used gray level co-occurrence metrics, local binary patterns, local phase quantization, and rotation variant local phase quantization, segmented basis fractal texture analysis, and we use all these methods to compose a multiple strategy for plant species identification. We use the kill nearest neighbors as a classifier, and all images were converted to gray levels, and we used the 10-fold cross-validation scheme. The value for Q is varied from 1 to 9 using only the odd values. We use 3 databases, Flavia, 1200 ticks, and Midrby databases. For the Flavia database, using the multiple strategy, we could achieve almost 98% of success rate. For the 1200 ticks database, we have a really nice result that was more than 8%, what is better than the literature. For the Midrby database, we achieved almost 95% of success rate, what is better than literature. The paper who proposed this database, which is composed by 52 species. And in conclusions, we agreed that all this kind of plant species identification helps the environmental preservation. The computational methods are very helpful in this task, and we can achieve high robustness and quality of texture descriptions methods for plant classification. So the multiple strategy of the feature vectors of the different methods provided a high improvement in the classification. Thank you.